So in the 2019 higher level question, under dynamic mechanisms, we were asked to create a displacement diagram for a cam movement. So we're told this cam is going to go from 0 to 60 degrees, rising of 60 millimeters with uniform velocity. So it is a constant speed. From 60 to 90 degrees, it has a dwell, so there's no upwards or downwards motion on the cam. We have from 90 to 270 degrees, it is falling with a UAR, which is really just acceleration and deceleration. And then it's returning back to 0 with a uniform velocity. So what we're told to do with the displacement diagram is to use a distance of 15 millimeters to represent each 30 degrees that this cam moves. So the first thing I'm going to do on the page is draw the straight line and set out the 12 different segments which each one is going to be 15 millimeters, and each one of these shows a 30 degree rotation of this cam. So the first thing, I'm going to mark off the 90 millimeters height, and this 90 millimeters height is marked off on the 60 degree line. This is a straight line because uniform velocity is just showing a constant speed. In this case, it is a constant rise. So next we're asked to look at is the dwell. So the dwell is just a straight line, so there's no motion upwards or downwards. So that's from 60 to 90 degrees. So those are the first two motions. So the next one is a little bit more difficult. It's from 90 degrees to 270 degrees, and we're looking at a UAR, so acceleration and deceleration. So the next motion on this displacement diagram is going from 90 degrees to 270 degrees, falling 60 millimeters. And what we're asked to do is show the motion of uniform acceleration and retardation. So this is where we're going to have an acceleration and deceleration at the same rate. So usually this path is going to be shown in a parabolic shape or a parabolic curve. So here we're going to use the rectangle method to show a parabola. So with a parabola and the rectangle method, what I'm marking out here is 6 heights or 6 distances. So I'm plotting them all out, and then I'm also going to need 6 lengths to draw the parabola method. So here So to draw the parabola, for every distance I'm going to go down, I'm going to join it up to the vertex. I'm joining this up to the vertex, and where it corresponds with our degrees line, I'm going to form this into a curve so we can see the acceleration, and I'm going to show the deceleration. So again, joining it up to the vertex of the parabola, matching up the points, and here is the curve for the deceleration. So the final part of the displacement diagram is from 270 degrees to 360 degrees with a motion of uniform velocity. And again, what uniform velocity is, in this case, it is a fall at a constant speed. So it is going to be just a straight line joined up. So the final step here is I'm just going to shade in our different motions. In the 2019 question, we have been told that there is no need, or it is not necessary, to draw in the cam profile. So just looking back at that, uniform velocity is a constant speed. So in this case, it went from 0 degrees to 60 degrees at that constant speed, and is rising up to 90 millimeters, which was told in the question. Dwell shows just a curved part of the cam, so there's no movement at all, so it is going to be a straight line. The uniform acceleration and retardation, so this shows an acceleration and deceleration. going at the same rate. So here we have to use a parabolic curve, and the easiest way to show this is with the rectangular method of creating a parabola. And again, the final motion was the 270 degrees to 360 degrees. Again, it was a uniform velocity, so it was at a constant speed as it dropped back. And then the cam would continue on with the same motions.